question? Really? Now we are going to talk about renal, tubular reabsorption and secretion. Okay. Reabsorption and secretion, which one is more important?
Reabsorption.
Quantitatively, reabsorption is more important, okay, from quantitative point of view. But secretion accounts for significant amounts of potassium ions and hydrogen ions, okay? Here you can see some substances, amount filtered, amount reabsorbed, amount excreted, and percentage of filtered load reabsorbed. Okay, not need to memorize it. Okay, but pay attention to the numbers now. For glucose, amount filter is 180 gram per day. All of glucose actually is reabsorbed. It means 100% of glucose is reabsorbed. Okay. Regarding bicarbonate, more than 99.9% is reabsorbed. Sodium, actually based on the needs of our body, is reabsorbed. 99% of sodium is reabsorbed. Chloride, 99%. Potassium, 87%. Pay attention to urea. It is important. Urea is a waste product. Am I right? It is a waste product, but as you can see, 50% of urea is reabsorbed. Actually, we want urea, a waste material, for what?
For osmolarity.
Actually, it is important in making medulla hyperosmotic. When there is water deficiency. We will talk about that in the next sessions, okay? But pay attention to this part. It is a waste material, but 50% of it is reabsorbed. Regarding creatinine, actually, as you can see, since it is a waste material, actually nothing is reabsorbed. Got it? Good. These are epithelial cells of tubules. Actually, reabsorption and secretions happen in tubules. Okay, for this reason, glomerulus is over. Okay, we are gonna talk about epithelial cells of tubules. Here, suppose that here is lumen of tubules. This membrane here, which is in direct contact with lumen, is called luminal or apical membrane. This membrane, this one, and this, are called basolateral membrane. As you can see, basolateral membrane is not in direct contact with lumen. Okay, it is in direct contact with interstitial fluid. We expect to have which capillary here? What's the name of capillary? Do you remember?
Yes.
Pretubular capillary, okay? You are familiar with basolateral and luminal membrane. Actually here, we have pretubular capillary, okay? Do you remember the blood pressure in pretubular capillary? 13 millimeter of mercury. Thank you. For reabsorption, first tell me the direction of reabsorption. From lumen toward pretubular or opposite? From lumen, it means the direction of reabsorption is in this way. From lumen toward pretubular capillary. Got it? For reabsorption, actually for reabsorption we have two main pathways. One is through luminal or apical and basolateral membrane. What do I mean by this one? I mean a substance which is supposed to be reabsorbed first actually must come inside the cell and then it must leave the cell. Am I right? Through basolateral and apical membrane. It is called reabsorption through transcellular pathway. This pathway is called transcellular pathway. Okay. There is another route for reabsorption. Okay, it has two steps. Okay, one, cells come inside and then it must leave the cell. Got it? Okay. Another route is actually through the spaces between the cells. This one. It is called paracellular pathway. Don't forget, all the time, paracellular pathway is passive because we have no transport mechanism here, no protein, for example, no carrier. Got it?
Yes.
Very good. But transcellular pathway might be passive, might be active. Actually, epithelial cells of the kidney are connected together by tight junction. These are called disjunctions. This junction is called tight junction. Actually, in the late part of nephrons, after distal tubule, okay, these junctions are too tight. Okay, for this reason, they don't allow anything to pass. Got it? They don't allow even water, the smallest molecule in our body. Water cannot pass through tight junctions. But in the early part of nephrons, they are not that tight. Okay? For this reason, water, small ions can pass through paracellular pathway. Got it? Very good. No question? Very good. Always paracellular pathway is passive. Something else which is worth mentioning is that we actually one cause for reabsorption is existence of a lot of sodium potassium found in which membrane? In what's the name of this membrane? Basolateral membrane. It needs ATP. It is primary active transport. 3 sodium ions are transported outward, 2 potassium ions come inside the cell, and after utilization of 1 ATP, it is called sodium potassium pump. Actually, it is one of the main items which increases reabsorption. In the kidney, we never have sodium potassium pump in luminal membrane. Okay? If, for example, if I ask you in the options, the existence of sodium potassium pump in luminal membrane is, for example, the most important factor for reabsorption.
False.
It's false. It's not correct. We never have sodium potassium pump in luminal membrane. In all parts of nephron. Got it? Sodium potassium pump actually exists in basolateral membrane. And it is one of the main items which increases reabsorption. Why? Because sodium actually is transported outward. What happens? Sodium concentration inside the cell decreases. And on the other hand, pump is electrogenic. Do you know about this property of sodium potassium pump? Sodium potassium pump is electrogenic. Do you remember? Because I haven't taught cell physiology to you. Do you remember the cause of actually being electrogenic? Yes or no? Yes? No? Maybe talk about the in cell physiology. Actually, suppose that it is one cell. Inside the cell, positive and negative ions neutralize one another. Okay. Excess negative charges actually accumulates immediately under the membrane. Okay, what happens? This is true about the outside the cell. Outside the cell, positive and negative ions neutralize one another. Excess positive charges accumulate near the membrane. Why here? Actually, negative and positive ions must attract one another. Okay, but the membrane doesn't allow. Okay, for this reason, as a result of attraction, they accumulate near the membrane. Got it?
Yes.
Suppose that this cell has sodium potassium pump. As a result of sodium potassium pump, 3 sodium ions, 3 of these positive charge ions, okay, exit the cell. Okay, what happens? We have 3 excess negative charges now. Okay, these negative charges actually are added to the membrane because they are not neutralized. Was it here or to here?
Yes.
This time, pumps actually transport 2 potassium ions, 2 positively charged ions inside the cell. What happens? These 2 positive ions begin to neutralize 2 of these negative charges. Am I right? And as you can see, after one cycle working of pump, we have one excess negative charge is added to the membrane. For this reason, we say sodium potassium pump is electrogenic. Got it? When sodium potassium pump work, what happens? Actually, we have decreasing sodium concentration inside the cell, and negativity increases or decreases? Negativity increases. Okay, inside the cell. actually sodium concentration in lumen high. Now sodium has a net driving force, a great net driving force toward inside the cell. Why? Because sodium concentration here is low and we have negativity inside the cell. Okay, for this reason sodium likes to move inside. Let's talk about the slides. Okay. Here you can see paracellular and transcellular pathway and existence of sodium-potassium pump in nominal membrane or in basolateral membrane. Don't forget, we don't have sodium-potassium pump in luminal membrane. You can see sodium-potassium pump in basolateral membrane. Regarding reabsorption. Reabsorption of water, reabsorption of solute. In proximal tubule. In proximal tubule, 65% of water, 65% of solute are reabsorbed. But in descending limb of loop of Henle, 20% of water is reabsorbed. Solute, we don't have active transport for solute reabsorption. In thick ascending limb, water is not reabsorbed. 25% of solute are reabsorbed. In distal tubule, water is not reabsorbed. 5% of solute is reabsorbed. In collecting duct, actually, water cannot be reabsorbed and actually little amount of solute is reabsorbed here. As you can see, it is supposed that it is loop of Henle. From this part on, there is no permeability to water. From this part on. Okay, after descending limb of loop of Henle, there is no permeability to water. What does it mean? It means actually tight junction is too tight to allow water to pass. Got it? As you can see, after descending limb of loop of Henle, there is no permeability to water. Except in presence of ADH. When there is water deficiency, actually from distal tubule on, okay, in the presence of ADH, these segments are able to reabsorb water. Okay? But when there is no ADH, there is no permeability. Got it? The question, which part of nephron doesn't have permeability to water, even in presence of ADH? Proximal tubule. Is it correct? Actually, proximal tubule is permeable to water, and in presence of ADH, there is no change in permeability of proximal tubule. 65% of water is reabsorbed. Got it? Okay. The next one, distal tubule. In the presence of ADH, distal tubule is permeable. Thick ascending limb.
Yes.
Yes, this one is very important. Okay. In the absence of ADH, okay, which part is permeable to water? Distal tubule. Thick ascendingly, thin descendingly, descending limb of loop of Handel. Yes. Okay, it is permeable. Okay, got it? These are my questions. No question? Okay, take a 10-minute break. See you at 9. Hadi Yusuf.